Students, after completion of divide and conquer and greedy programming problem solving methods, will proceed towards dynamic programming, a unique problem solving method. So this problem solving method is applied when all the previously learned problem solving methods are not useful. In this particular problem solving method, we simplify the complicated problems by breaking down into simpler subproblems, small subproblems. But this method has also been applied in divide and conquer method, that the problems are also divided in subproblems. But in divide and conquer, we see that the problems are not dependent on each other. They are independent, so that those problems can be solved independently. In this case, if the problems are not independent, means the problems are dependent on each other, then this problem or this type of problems cannot be solved using divide and conquer method. So if subproblems, there is one more feature. So this feature is also understood. If the subproblems can be nested recursively inside a larger problem. So every subproblem has a larger subproblem as it's a parent problem. So once you solve a subproblem, the solution of that problem is provided to its a parent problem and then to its and so on, so that to finally get a solution of the larger or complex problem. So if we want to solve this kind of problems, then we need to apply a dynamic programming method. In divide and conquer, we have subproblems which are independent of their solutions. So in dynamic programming, we have dependency of the subproblems. Second, these subproblems are overlapping in dynamic programming. So we will use a dynamic programming method. So these subproblems are a complex problem can be solved optimally by finding the optimal solution to the subproblems. Then it is said as optimal substructure. When we want to solve a problem, then we need to find a solution of a smallest subproblem. If we are able to find a solution, a design of a smallest subproblem, then this problem can be found a mathematical formula or mathematical method or a way of finding a solution can be found a smaller subproblem. This solution is known as optimal substructure. Then this optimal substructure can be further be extended for finding a solution of a larger subproblem. So these are some of the examples of a dynamic programming or the problems which can be solved using dynamic programming method. Few of those are here: matrix chain multiplication, longest common subsequence, traveling salesman problem, and rod cut problem. So we have studied different problem solving methods, but this problem solving method has its own unique problem solving technique. So dynamic programming algorithm is designed using the following steps. So we have to follow these steps. First step is to characterize the structure of an optimal solution. Structure of an optimal solution means once we divide the problem, a complex problem, into subproblems, then this particular problem can be solved using a unique method, unique formula. So this particular method or formula is known as optimal solution. Then this optimal solution is applied to other subproblems to solve the problem in a recursive way. This is the second step. So recursively define the value of an optimal solution. Once we found a solution for one subproblem, then the solution of that subproblem is also applicable to other subproblems. And then this subproblem is recursively applied to all other subproblems for solving the solution. As we understood that each subproblem is a part of a higher subproblem. That is why we'll get a hierarchy of the subproblems, so that we'll try to solve the problem in a bottom-up method. This is a third step. Compute the value of optimal solution, typically in bottom-up fashion. Construct an optimal solution from the computed information. Once we solve all the problems in a bottom-up method, we'll directly get a final solution. This is known as optimal, the final solution, which is computed using dynamic programming. This is fourth step. So let's understand how a rod cut problem, it's one of the very popular dynamic method which is applied to this rod cut problem. So this rod cut problem is explained here. So it has a length which is defined with I. So 1, 2, 3, 4, 5, 6, 7 and 8. The respective values of the length 1 is 1. Length 2 is 5, length 3 is 8, length 4 is 9, length 5 is 10, length 6 is 17, length 7 is 17, and length 8 is 20. It means if we as a shopkeeper want to sell a rod of length 2, then we will be selling this rod length 2 for a price of 5. If we sell a rod of length 6, then we'll sell this rod for a length 17. It means if we sell a rod of length 6, we'll get a profit of 17. So this is how the problem is defined. What we want to achieve is we want to get a maximum profit of selling a rod of some particular length. For example, if we have a rod of length 4, then the rod of length 4 can be cut in or sold in different ways. If we sell a rod of length 4, then we'll directly get a price 9, the profit 9, which is already defined here. But if we cut a rod of length 1 and 3 size, then the profit of 1 is 1, and the profit or price of rod length 3 is 8. It is defined in the table. So 8 plus 1 is equal to 9. It is similar to the rod of length 4 what we sell it in the market. But if we sell the rod by cutting it in two parts, which is of length 2, then we'll get a profit 5 plus 5 is equal to 10. So this 10 profit is definitely larger than the previously defined process of cutting and selling a rod into the market. So if we have got a rod of length 4, then cutting and selling rod with different methods is defined here, and the respective profit is defined in the right side of the table. So if we look at the table, then anybody can easily understand that cutting a rod of length 2 into 2 pieces, P2, P2, 5 plus 5, 10 is the maximum profit that we can get. So by this particular example, we can understand that if we can cut the rod, any rod of length n into 2 to the power n minus 1 ways to find a maximum profit out of it. So this is what the example is. Then solving this example, see this rod length is 8, it's okay. But if the rod length is n, this rod length is say 100 meter or 10,000 meters, then the problem is going to be very complex and it cannot be solved easily. That is why we are going for machine learning method, a machine method. A computation can be done by a machine or programming to make it more easier. So the solution of a problem. So let's look at the solution of this particular problem. If a rod length of 1, we will sell a rod length of 1 will achieve a profit 1 which is already defined. So if we sell a rod length of 2, so this is B is benefit, or you can see it as a profit. A rod length of 2 is benefit. What we can do, either we can sell a rod length with a 1 and 1 part. So 1 length and this is 1 length. Or we can directly sell a rod with the length V2. So V is a rod length V2. So if we sell a rod with the length V2, or this will cut it in 2 parts, what we can achieve out of that maximum we can select for B2. Then the second thing what we can do here is, we for a profit 3 we can either cut a rod of length 1, the remaining is profit 2 which is achieved here, B2 is achieved here, the maximum profit is achieved, that we can directly store here. So this particular B2 is a sub problem which is already solved here. B2 is the first part. Second part is, a rod can be cut with the rod length V2 plus B1. B1 is a problem already solved here, the rod length 1. Or the problem with the rod of length 3, V3, it's directly solved here. So this maximum benefit can be achieved for B3, rod length B3. For rod length B4, rod length V1, or the remaining is B3. B3 is achieved here, so it's a subpart. So B3 plus V1 can be done. V2, rod length of V2 plus B2, profit B2 is achieved here, so it can be stored. V3, rod length V3 plus remaining rod length B1, it's already achieved. So this is, or you can directly completely sell a rod of length 4 directly. The same will continue for a rod length of N. So this we can achieve. So what we can achieve, the maximum benefit for a final value of B of rod length N. So for solving this, we can write an optimal substructure like this. Maximum of U1. U1 is rod length. This rod length 1 is achieved with B of I minus K. K is the value, the partial value, the remaining value of that particular length. So Ui plus B I minus K is done here. Then we will get this as optimal substructure, and this optimal substructure is then finally put into a program. So this is a program that we can write. So this particular program is written for implementing a rod cut problem. So this is what the optimal substructure is. Maximum of Q, comma, the remaining. This Q is the output, what we have achieved as a B1, B2, B3, previously achieved output. And this rod cut is a recursive problem which is shown here for this particular example. So this cut rod will again and again recursively solve for all n minus I problems. So what we do, if rod length is 0, then we'll return 0. We are not going to bother because rod length is 0. Q is equal to minus infinity defined here. For rod length of 1 to n, what we do is we'll expect the maximum out of rod length Q and the remaining profit plus cut rod. Again, go on solving recursively again and again the larger size of problem for achieving the final result as a return Q. This is a rod cut problem, what we can understand for a dynamic programming. But just solving rod cut problem is not enough, because we have got a matrix for solving the problem, and finally we are not going to run away by just telling the maximum profit. We have to tell that which are the rod length allows us to gain a maximum profit. So we need a memorization, because when we are executing the program, then we are also supposed to keep track on which particular rod length will provide you the maximum profits. So this memorization rod cut problem will allow us to store the index of those particular rod lengths which has provided the maximum profits. So this is what the memorized rod cut algorithm is. So by understanding this, this is one and the similar that we have achieved with this optimal substructure, but here just we are trying to store the indices of the particular rod cut size, which allows us to store it in the memory. So we'll try to solve some of the problems in the next lecture, with which we can understand the actual implementation and finding the result of the similar rod cut problem. Thank you.